This is the second video in the series on reference properties. So in the first video we talked about the importance of reference properties for comparing multiple scenarios or configuration of a system in one experiment as opposed to performing multiple experiments each with a different configuration. So if you haven't watched the first video, I would suggest that you stop this video and go back and watch the first video of the module to fully understand the importance of what we're going to talk about in this video. So let's do a quick recap on the objectives of this module and also the problem description. So as for the objectives, we're going to learn how to define reference properties to assign values to different object properties in our model. We will also learn about experiment controls and how we can define multiple scenarios in one experiment to perform comparisons. Specifically, we would like to evaluate different configurations of a Subway restaurant, and in order to perform comparisons, we will look at side-by-side smart plots. So we're going to talk about how we can interpret the results by looking at the side-by-side smart plots as a result of using controls in our experiment. The description of the system is same as before. So we have an arrival rate of 32 customers per hour, and you can see the service times here. 70% of the customers get their sandwich toasted, and 30% get cold sandwiches. Under the current policy, we need to maintain FIFO throughout the system. So, in other words, customers that want cold sandwiches cannot pass those that are waiting in the oven station to have their sandwich toasted. And also we have bulking, and whenever customers arrive, they'll look at the number in the system, and if there are more than 6 people in the system, they will bulk. So if I go back to our model that we built in the previous video modules, so you can see the general structure of the model here. So if I run the model, you can see that we have hot customers, those customers that get their sandwich toasted, represented by the red symbol, and cold sandwiches or cold customers represented by the light blue symbol. We have add-on processes that basically change the symbol of the entities when they're created based on their type. So if I go to my add-on process here, I have let me go ahead and stop the model so you can see the values that I assign here. So if my recently created entity is of type cold, which happens with a probability of 30%, the processing time on the oven will be 0. Otherwise, it'll be a random variable, triangularly distributed with the parameters specified in the problem statement. And we also assign the symbol for the cold customers by changing the model entity.picture state. You can also see that we have another decide step that basically implements our bulking logic. So my decide step is condition based, and as you can see, customers bulk if the current number in system is greater than 6. So let me go back to my slides here. So we're interested in evaluating the performance of the system during lunch rush, and specifically we would like to answer the following 2 questions. First, we would like to add 2 additional resources to reduce lost sales, and the question is where to put these 2 additional resources. So keep in mind that the resource can be either an oven or a new drink machine or a worker at any of these stages. The other question that we would like to find out is what is the best operating policy under the new system configuration? Should we allow passing or just stick with the current no passing policy? The performance measures will remain the same. So we're going to use server utilizations, average time in system for all customers, expected number in system, percentage of customers that bulk in average time in system per customer type, in other words, cold and hot sandwiches. But we will primarily use the percentage of customers that bulk to compare different scenarios or system configurations. What we basically need to do is evaluate different system configurations under the two policies that we have. In fact, if we would like to find the optimal system configuration and policy, we need to evaluate all possible scenarios. So when you think about this particular problem, we would like to pick 2 out of 5 stages for capacity expansion purposes. So basically we have a selection of 2 out of 5 options, which gives us 10 scenarios. And since we have 2 operating policies, we have a total of 20 scenarios that we need to evaluate using simulation. So in this video, our focus will be on the first item, where we analyze the performance of the system under the current operating policy with different capacity allocations. Before I show you how to set a reference property, I would like to go to, I have my model selected here, and I would like to go to definitions and the properties of my model. And as you can see, we have the built-in properties for our model in the properties tab, but we don't have any user-defined properties in our model yet. So now what I would like to do is define reference properties for the capacity of my 5 servers. So what I'm going to do is select the first stage, and then instead of specifying the value directly in the properties window of the first server, I can simply right-click on the initial capacity property and go to set referenced property, and you can see all different options that Simio gives me. But what I would really like to do is defining a new reference property. So I'm just going to click on create a new reference property, and I can give it a name. So I'm just going to call it bread capacity and say OK. So now when this little green arrow appears, it means that we're using a reference property to set the value of the initial capacity property of this server. Now if I go to my model definitions and properties, now you can see that we have this user-defined property that appears in the properties tab, which is our bread capacity. And if I click on it, you will see that the initial value or the default value is set to 2. So we can modify this. So let's set it to 1. So now when I go back to my model, this value refers to the value that I set for my reference property. So my capacity of the server will be 1 if I run the model. So I can go ahead and run my model. And as you can see, I only have a capacity of 1 because I'm referring to my reference property to know what the initial capacity of this server is. Also, if I click on the facility view, you will see the properties of the model. And if I click on the general under the controls category, you will see that a reference property appears as a property of our model. So we can stop the model and change our bread capacity, let's say to 2. And now, instead of changing the capacity directly in the object, from the object properties, I can change it directly from the model property. And if I run my model, now you can see that we have a capacity of 2 on the first server. So this is a really nice feature because we can simply modify different reference properties in our model and run our model in the interactive mode and see how the model behaves. So that's what I'm going to do now. I'm going to define reference properties for my other servers. So I'm just going to select my oven and set a reference property for my oven capacity. So again, create a new reference property, oven capacity. That's the name I would like to give to this reference property. Say OK, and again you will see this little green arrow. Let me go ahead and define reference properties for my other servers. So set the reference property for the veggies, veggies capacity. OK. Select cashier, initial capacity, right click, create new reference property, cashier capacity. And finally, my drink machine, set reference property, create new reference property, and drink capacity. So now if I go to my model properties, you will see that I have all my reference properties listed here, and I can set their default values. I'm going to default all of them to 1, and for the rest of them we should have 1 already. That's right. So now if I go to my facility view, click on my model, you will see that we have all our reference properties listed here, so I can modify them. So let's say I want to have 2 for the first 2 stages, and I can run my model and basically see how the model behaves as it runs. And as you can see, we see a maximum of 2 model entities in the first 2 stages because we set the capacities of these 2 stages to 2. So as you can see, this makes it really easy for us to modify different properties of our model to run different scenarios in the interactive mode. Also, note that whenever you set the value of a reference property to a value other than its default value, it will appear as a bold font in the properties of the model. So as you can see, the 1s appear in a regular font, and the 2s that I have appear as a bold font. So also, let me go back to my experiment, and now when I go to the experiment, you will see that not only we have the previous components that we had before, but now we have a new set of components under the controls category, which are basically our reference properties. So as you can see, in fact, this is the original scenario that we ran, our first scenario, having first 2 servers with 2 units of capacity, and the rest have 1 unit of capacity. And this is a nice feature because it allows me to define multiple scenarios in the same experiment. So now I can click on this little box here and create another scenario, and then set my parameters however I want them to be. So for example, let's say in the second scenario I want my bread capacity to be 2. I will leave my oven capacity at 1 and my veggies capacity to 2. So I can also go ahead and define other scenarios. Now this time I will set the first one to 2 and cashier to 2. And the fourth one I can set the first and the last stations to have 2 units of capacity. And of course I can go ahead and define my other scenarios here, which is what I'm going to do next. So here I have listed all my 10 scenarios or 10 parameter configurations using reference properties. And before I run this experiment, I would like to show you one other thing. In fact, if we go to Model, Definitions, Properties, we can set which reference property we would like to appear as control in our experiment. So let's say I don't need the first reference property, bread capacity, to appear as a control in my experiment. I can simply select bread capacity, and under the general category properties, set the visible property to false. And again, as you can see, it appears as, in a bold font. So that means I've changed it from the default value. So if I now go to my experiment, which I have renamed, by the way, to current policy with referenced properties, you can see that now I only have 4 controls in my experiment. So basically, I set Simio that I don't need the bread capacity to appear as a control in my experiment. So let me go back and actually undo what I just did, because I need it in my experiment. So now it again appears in my experiment. Now I'm going to click run, and you will see that all my 10 scenarios will run simultaneously, and we will be able to compare the results as the experiments are running for these different parameter configurations. So now my experiment is complete, and I can directly compare my 10 scenarios or 10 parameter configurations here in my experiment table. So I can compare time in systems, number in systems, and so on, utilizations. However, since the primary performance measure that we're going to use is the bulking percentage, I'm going to just move my bulking percentage to the first column in my response group. So now we can see how the bulking percentage changes as we allocate our additional 2 units of capacity to different servers. The other nice thing is that if we go to response results, now we see the SMORE plots for different scenarios 1 through 10, all in one place. So I can make direct comparisons of, in this case, I have selected my percentage of bulkers as the main response that I'm looking at here. So I can make direct comparisons of the SMORE plots right here, all in one place. And as you can see, it seems that my second scenario, scenario 2, has the minimum percentage of bulking. And so you can hover the mouse over the SMORE plots and see different values associated with its different components. Let's look at scenario 2. So scenario 2 is the case where we have 2 units of capacity at bread and 2 units of capacity at veggies station. And in fact, before we even did this analysis, we could expect that this scenario would be the best possible way to allocate our 2 additional resources to our system, because when we look at the original model where we have 1 unit of capacity for all servers, and as you can see, we had of course the experiment controls have changed because we modified the model, so let's just ignore these. These are basically 1. When we ran this, these values were all 1. So the bulking percentage at that time in that experiment was 9.88. But when we look at the utilizations of the servers, we see that the bread station and the veggies station had the highest utilizations. Basically, these were our 2 busiest stations in the original model. So we expect that the best allocation of the 2 additional resources is to allocate those to these 2 stations that have a higher utilization than the rest of the stations. And that is why we see the most or the highest improvement in our bulking percentage when we allocate the 2 resources to our bread and veggies stations, which also you can see in the side-by-side SMORE plots.